So today our topic is enthalpy of solution, enthalpy of dilution, then spontaneity, entropy, free energy. These are the topics that we are going to discuss. Enthalpy of solution. You know, when a solute dissolves in a solvent, sometimes heat energy may liberate or heat energy may absorb. And that is enthalpy of solution. For example, when NaOH dissolves in water, there is liberation of heat energy. That is an exothermic process. At the same time, when ammonium chloride dissolves in water, that will absorb heat energy. So you will get a cooling effect. It is enthalpy of solution. So in order to get a specific definition, we limited the quantity as 1 mole. So what is the definition of enthalpy of solution? Enthalpy of solution of a substance is the enthalpy change when 1 mole of it dissolves in specified amount of solvent. That is enthalpy of solution. But this enthalpy of solution depends on 2 factors. The first one, lattice enthalpy, and the other one, hydration enthalpy. Lattice enthalpy, we discussed it in detail. You know what is lattice enthalpy. It is the energy required to dissociate the solid ionic compound into its gaseous ions. Here you can see the solid ionic compound AB has dissociated and produced A plus gas and B minus gas. This A plus gas and B minus gas combines with the water molecules. At that time, there is an energy change, enthalpy change. That is represented using hydration enthalpy. So these are the 2 factors affecting enthalpy of solution. Now enthalpy of dilution. What is enthalpy of dilution? After preparing a solution, if we add excess quantity of water or solvent to it, what happens? It will be diluted. And during that dilution, there will be an energy change or enthalpy change. That is enthalpy of dilution. For example, if we add water to an acid solution, what happens? For example, HCl solution, what happens? Huge amount of heat energy will be liberated. Large amount of heat energy will be liberated. Liberation of heat energy. That heat energy can be considered as enthalpy of dilution. So enthalpy of dilution is the heat withdrawn or heat given by the system, heat withdrawn from the surroundings, or the heat given by the system when additional solvent is added to the solution. The enthalpy of dilution of a solution depends on the original concentration of the solution and the amount of solvent added. If the amount of solvent high, the enthalpy change also will be high. And if the initial concentration is high, enthalpy change also will be high. Now, spontaneous process. What is meant by spontaneous process or spontaneity? A spontaneous process is the process which takes place by its own accord. A process by itself, without the help of external agency. That is a spontaneous process. So spontaneous process will take place only in one direction. And the reversible process cannot take place spontaneously. That need the help of an external agency. That is known as a spontaneous process. So we can define a spontaneous process as an irreversible process, and the reversible process is possible only by some external agency. So a spontaneous process is an irreversible process, and the forward reaction will take place by itself. The backward reaction takes place only with the help of an external agency. That is spontaneity. And what is the driving force of this spontaneous process? Why it is taking place by itself, without the help of an external agency? What will be the driving force? For example, you consider burning of a paper. You have to first ignite the paper, initiate the burning. Then it will burn continuously without the help of an external agency. So spontaneous process can be classified into two. First one, spontaneous process which need initiation, and the second one, spontaneous process which does not need initiation. Burning of pepper is a spontaneous process which need initiation. But rusting of iron, that is a spontaneous process which does not need initiation. Evaporation of water in an open vessel, that is a spontaneous process which does not need any initiation. So there are two types of spontaneous process. The one is which need initiation, the other one is which does not need initiation. And in this case, in the burning of paper, that process is taking place spontaneously, and you know during burning of paper what happens? Heat energy will be liberated. Liberation of energy. If there is liberation of energy, system will go to more stable state. All the systems prefer stable states. Therefore, the releasing of energy or decrease in energy may cause the spontaneity. So one of the criterion for spontaneous change is decrease in enthalpy. One of the criterion for the spontaneous process. But when we think about the evaporation of water in an open vessel, actually what is happening? The system is absorbing energy from the surroundings. Then it is evaporating. So here the energy is increasing. There is an increase in energy. That means system is going to an unstable state. Then how it will take place spontaneously? Then we have to identify another factor, which is the reason for the spontaneous process. Here we can think about the evaporation of water. Here water, the liquid state, that is an ordered state. When it evaporates, it is going to gaseous state, a state of disorder. There is no particular pattern or arrangement, or intermolecular attractions are very weak, free to move. The molecules are free to move here and there, no restrictions. A disorder is there. So we can understand that the system likes disorder. So it has a natural tendency to go to the more disordered state, that is gaseous state. When we connect it with our life, we also like disorder, isn't it? You like intervals than the class time. This lockdown period, you are not interested in it. Actually, you want to go out. Why? Because you like disorder. That is the reason. Everything likes disorder. The system also likes disorder. That may be the reason for the spontaneous evaporation of water. So the second criterion for a spontaneous process, increase in disorder. And in order to mention that disorder, we derived we introduced a new term, that is entropy. Entropy is the measure of disorder. So increase in disorder or increase in entropy, that is another criterion for spontaneity. So we identified two things, decrease in enthalpy or increase in disorder. Here, our topic is entropy. What is entropy? We have to study it in detail. Entropy denoted by the symbol S. And what is entropy? Entropy is the measure of disorder or randomness. Entropy is a measure of the degree of randomness or disorder in the system. The greater the disorder in isolated system, the higher is the entropy. And the change in entropy That is represented as delta S. Change in entropy is represented as delta S. And how will you measure this change in entropy? Is it possible to measure the disorder? No. We cannot measure it. We can measure the heat energy liberated or heat energy absorbed. That is possible. But it is very difficult to measure the disorder. Then how can you find out the entropy change? Change in entropy. There is an equation to find out the change in entropy. Delta S is equal to Q reversible by T. What is Q reversible? It is the heat energy absorbed or liberated when the system is in equilibrium. For example, you consider melting of ice. At 0 degrees Celsius or at 273 Kelvin, the two processes will take place. That means melting and freezing, fusion and freezing. These two processes will take place. And if we supply heat energy at that particular time, that heat energy will be completely utilized for the freezing, utilized for the melting of the ice. And there may not be any change in temperature. So here temperature is constant, T. Q reversible. So we can take it as the enthalpy change. But at that time, T will be constant. So it is the equation to find out change in entropy, delta S. Now, what is meant by total entropy change? Delta S total. Here, you have to remember the definition of the system. What is a system? The part of universe under investigation. And surroundings, the rest of the universe. So, system plus surroundings equal to universe. So, total entropy means entropy of the universe. What is happening to entropy of the universe? That is the question here. So, delta S total means delta S system plus delta S surroundings. That means entropy of the universe. So, during a spontaneous process, delta S total is greater than 0. That means positive. You note it clearly. What happens during the spontaneous process? Entropy of the universe is increasing, or disorder of the universe is increasing. Universe is going to more and more disordered state. Entropy of the universe is increasing during a spontaneous process. In the course of a spontaneous process, entropy of the universe is increasing. So it is very important. When a system is in equilibrium, the entropy is maximum and the change in entropy delta S is 0. So when a process is in equilibrium, delta S total, not the delta S of system or not the delta S of surroundings, delta S total is 0. It is simply given as delta S is equal to 0, but it is not delta S total is equal to 0, or delta S of universe is 0. You will understand it from your experience, your behavior. That will affect the society, isn't it? Your nature, that will affect the society. You and the society interconnected. What you are giving to the society or what you are taking from the society, that is important. So it is entropy. Now we can solve some problems here. Some conditions are given here. Predict in which of the following entropy increase or decrease. A liquid crystallize into a solid. Liquid crystallize into a solid, which is more ordered state, solid state. When liquid changes to solid, the order increases. That means entropy decreases. Delta S will be negative. Delta S is negative because liquid changes to more ordered solid state. Second one, temperature of a crystalline solid is raised from 0 Kelvin to 115 Kelvin. So as the temperature increases, disorder increases, isn't it? When ice is heated, it will melt. Ice is ordered state and the liquid is, the disorder increases. And therefore, delta S is positive in such a case. Entropy increases with the temperature. Now the decomposition of sodium bicarbonate. Sodium bicarbonate decomposes to give sodium carbonate, carbon dioxide and H2O. Here you can see carbon dioxide in the gaseous state, H2O also in the gaseous state. So a solid substance produces gaseous products. Therefore, we can see an increase in entropy. Delta S is positive. And the fourth one, H2 gas gives to H gas. 1 mole is changing to 2 moles of gaseous products. So surely there will be an increase in entropy. Delta S is positive because number of moles increases. Now Gibbs energy and spontaneity. Here we mentioned there are two factors: enthalpy, decrease in enthalpy and increase in entropy are the driving forces of a spontaneous process. Or these two are the criteria for a spontaneous process. So in order to mention or specify a spontaneous process, we have to consider these two separately. If we will get these two factors in a single property, that will help you to explain it very easily. And Gibbs energy or Gibbs free energy will help you to describe the spontaneity of a reaction. What is Gibbs free energy or Gibbs energy? It is the maximum useful work that can be done by a system, and it is defined as G is equal to H minus Ts. G Gibbs free energy, H enthalpy, T temperature, S entropy, T in Kelvin scale. And G Gibbs free energy, G is an extensive property and a state function. The change in Gibbs energy for the system delta G system can be written as delta G system is equal to delta H system minus delta Ts, delta in bracket Ts. That can be expanded as T delta S system minus S system delta T. But we know here the temperature is constant. So this term will become 0. Therefore, our equation delta G system is equal to delta H system minus T delta S system. Usually we will not write this system here. So simply delta G is equal to delta H minus T delta S. And this equation is known as Gibbs equation or Gibbs-Hellman's equation. Gibbs equation or Gibbs-Hellman's equation. So delta G is equal to delta H minus T delta S. It is Gibbs-Hellman's equation and you have to remember it. There's a lot of applications. Don't forget it. Now the criterion for a spontaneous process is delta S total is positive. From that, we can derive the criterion in terms of delta G. And here you can see it is derived. Delta S surroundings, delta H surroundings by T. Delta S surroundings this is from the equation for the entropy change in entropy. Delta S surroundings equal delta H surroundings by T. But you know, delta H surroundings means the heat energy liberated to the surroundings or heat energy taken from the surroundings. If it is taken from the surroundings, the heat energy is going to the system. Or if it is coming out of the system, given by system and gained by surroundings. So we can identify, understand in magnitude delta H system is equal to delta H surroundings. Or delta H surroundings equal to minus delta H system. So we can rewrite it as minus delta H system by T. Now we have written delta S total is equal to delta H system plus delta H surroundings. And what is delta H surroundings? Delta H system by T minus delta H system by T. Substitute the value here. Delta S total is equal to delta H system plus minus delta H system by T. Multiply this with the delta T. Sorry, multiply it with the T, not delta T, multiply it with the T. Then T delta S total is equal to T delta S system minus delta H system. So if you take a negative of this minus of delta H minus T delta S. Delta H minus T delta S, you know it is G. So minus of delta H minus T delta is minus G. So T delta S total is minus G. T delta S total is minus G. When a process is spontaneous, when T delta S is positive, or delta G is negative. When delta G is negative, that process will take place spontaneously, or we can say the overall criterion for a spontaneous process minus delta G. The delta G value should be negative. So we can conclude all that we discussed here. If delta G is negative, the process is spontaneous. If delta G is positive, the process is non-spontaneous. If delta G is zero, the process is at equilibrium. Free energy change of a chemical reaction allows prediction of the spontaneity of the chemical reaction. If delta G is negative, that process is spontaneous. Prediction of the useful work that could be extracted from it. Delta G is equal to minus W useful. Delta G is equal to minus W useful. So here some problems, we can see some problems. The first one, at 273 Kelvin, ice and water are in equilibrium and delta H is equal to 6 kilojoule per mole. For the process, H2O gives H2O, H2O solid gives H2O liquid. What will be delta G and delta S? Here you can see equilibrium. If it is equilibrium, what is delta G? Delta G is equal to 0. If it is equilibrium, delta G is equal to 0. And now we have to calculate delta S. What is the equation to calculate delta S? Q reversible by T, or delta H by T. That is the equation to calculate delta S. Delta H is 6 kilojoule per mole. When we convert it into joule per mole, 6 into 1000 joule per mole divided by T. What is the temperature? 273. So 6 into 1000 divided by 273 equal to 21.97 joule per Kelvin per mole. Another question. Calculate the entropy change involved in the conversion of 1 mole of liquid water at 373 Kelvin to water vapor at the same temperature. Latent heat of vaporization of water, delta H vaporization, is equal to 2.257 kilojoule per gram. So here you listen the unit kilojoule per gram. But for the calculation, we require it in per mole. So delta H vaporization, if you want to calculate delta H vaporization per mole, you have to find out it for 1 mole. It is water, isn't it? Water, what is, it is for 1 gram of water. So what is the mass of 1 mole of water? 18 grams. So if you multiply it with 18 grams, you will get the value for 1 mole. So Q reversible 2.257 into 1000 into 18 equal to 40,626 joule per mole. Here the Q reversible means delta H vaporization. And now what is entropy? Delta S is equal to Q reversible by T, or delta H vaporization by T. That is equal to 40,626 divided by 373 equal to 108.9 joule per Kelvin per mole. Okay, today we can stop it here, and you have to study it in detail. Study well, and in the next class we can see the remaining part. Okay.